Hi, my name is Eduardo Ochs, and this is my video for the EmacsConf 2025. Its title is Some Problems of Modernizing Emacs, and that is the same title as a video that I tried to record in March, but my video from March had a good beginning and a bad rest, and I thought I can't release that because the rest is very bad. I need to re-record the last part of the video, but I never did that. So this video is going to be the first 12 minutes of that other video with another ending, and in this other ending I'm going to show some things that are very easy to test, and if people are interested, then the rest of the old video will make more sense. Anyway, let me start. Hi, my name is Eduardo Ochs. I'm the author of an Emacs package called EV, and the title of this video is Some Problems of Modernizing Emacs. Here is a summary of the main themes of this video. I'm going to talk mainly about these four things here. The first one is that Emacs have changed a lot in its recent versions, and now it has lots of types. So if we want to look under the hood and to understand what Emacs really does, we are going to stumble on lots of types, and the current tree of classes and types looks like this. That is quite big. The second theme is that people used to say things like anyone can learn Lisp in one day. I'm going to explain this quote, and I'm also going to show that now this is gone. Anyway, this is a very short summary. Details soon. I will also show how to display better inner views of Emacs objects. I'm going to define what is an inner view, of course. The main trick is that we are going to use one of the ways of displaying internal objects, that is the CLPrint family of functions, for example CLPrint1 to string, and here are some examples of the kind of output that we are going to see. For example, if we run these two lines here, the first line defines a function foo, and the second line sets O to the internal view of the definition of foo. In older Emacs, O would be just a list that would look very similar to this line here, but in newer Emacs, the result of this, I mean the contents of O, is this thing here that looks quite different from this definition here. So in older Emacs, the contents of the function cell of foo would be a node style lambda that would be just a list like this, and in newer Emacs the contents of O would be a vector like lambda. Looks for the square brackets here, this is a vector, but it is preceded by a hash sign, so this is what we call a vector like lambda. And vector-like lambdas do not have a canonical printed representation. They have at least two semi-canonical printed representations. The first semi-canonical printed representation is this one. It's generated by a family of functions with names like print1. And the second semi-canonical printed representation is like this. It looks like a list looks somewhat like this definition of foo here, but it has this dynamic bind symbol here. And it turns out that when we use the CLPrint family of functions, we can reconfigure how things are printed, and I'm going to show several interesting ways of reconfiguring how lambdas are printed, and one of the ways is going to be like this. We can also use the CLPrint functions with my indentation tricks to display how types or classes are viewed internally by Emacs, and this is a big example. This is what Emacs considers as being the definition of the type CL structure class, and it is this big thing here. I edited it very lightly. I just deleted some line breaks here. And another thing that I want to explain is that Emacs has some help functions that I have never liked. For most people they are good enough, but for me they aren't. They are, well, I'm going to say more about this later. And for example, if we want a description of what is this type here that we just saw in its internal view here, we can run either describe type or my variants of describe type, and we get a help buffer that looks like this, in which these blue things that are underlined are buttons in the classical sense. You can click on these buttons or type return on these buttons, and you will be taken to another help page that is generated dynamically, and you can navigate back and forth and, well, whatever. And I'm going to explain my problems with these kinds of help buffers and what I'm trying to do to overcome these problems. One of my slogans in this video is going to be this one: anyone can learn Lisp in one day. And this is a part of a bigger quote that I took from a keynote presentation by Abelson and Sussman, who are two dinosaurs of computer science. Here is the full quote. Anyone can learn Lisp in one day, except that if they already know Fortran, then it would take 3 days. This is a frame of the video. And by the way, I am going to add this. And if the person is starting with Doom Emacs, then it would take 5 years. Why? I'm going to explain why. This is how Emacs Lisp used to be. If we execute these two expressions here, the first one is, each symbol can have two values. One is the value as a variable, and another one is the value as a function. If we run this, we store 42 in the value cell of the symbol foo, and if we run this def one here, it stores a certain anonymous function in the function cell of the symbol foo. In Emacs, until some time ago, if we did that and if we run this expression here, the result would be 42 because of this line here, and if we run this line here, the result would be the anonymous function corresponding to this defun here. But now this have changed. The result of this thing here is this vector-like lambda here, but that doesn't matter much now. So until some time ago, if we did that and if we run this expression here, foo, Emacs would do this. It would replace the first foo by this anonymous function here. It would replace the second foo by the value of foo as a variable that is 42, and it would evaluate this, and the result would be 420. So again, we used to have this slogan here: anyone can learn Lisp in one day, but now this is gone. Let me talk a bit more about why. The title of this slide is Lambdas for Beginners Broken. And if we run this, as I've shown in the previous slide, in the old style, in older Emacs, where the result of symbol function foo would be this anonymous function here, and now we get this strange thing here. So this is an old style lambda. This is a vector-like lambda. And until the middle of 2024, beginners could learn a lot of Lisp by thinking only in terms of objects like this. So this is a function and this is an anonymous function. And they would learn how to draw const cell diagrams like this. This thing here, this thing here. They would think on lists as being these trees here. And they would be able to understand a lot of Lisp just by thinking in these terms. And then vector-like lambdas started to appear in many places. And if we use vector-like lambdas as in the wide sense to mean all the new objects, these new objects that are difficult to visualize, they also started to appear in many places. This is a continuation of the previous slide. This part here is a copy of things that were in the previous slide. And before 2024, beginners could open black boxes like this. They could try to see what was in the function cell of the symbol foo, and they would see something elegant and mind-blowing. And they would start to love Lisp immediately. Now what they see is a tiny part of a very complex structure that is very powerful, but it's very difficult to understand. And now our beginners are overwhelmed instead of mind-blown. Note that I said black box here. Let me explain the term. We can open what's inside of foo. We can open foo to see the contents of the symbol foo, and we can try to see what's in the function cell of the symbol foo. So we can open the box, but what we get is something very difficult to understand. And so I'm going to say that when this happens, that box is black. It's not totally black. We can open it, but we don't understand what is going on there, so we declare that that is black. And when these things started to happen, I was overwhelmed. And in this video, I'm going to pretend that I was not the only person that was overwhelmed by these new structures that are not so elegant as the one that we had before. Anyway, in the beginning of the video I said that I was going to replace the second part of my video from March by something that was very easy to test. So this is a quick demo for the very impatient. I'm recording this in December for the EmacsConf 2025. This is the demo that I'm going to present. The idea is that people can run the demo first time just to check that everything works and to have a notion of how things look like, and then in a second moment they can rerun the demo more slowly to understand what each step does. So we are in a file called 00 try this, and the idea is that we can execute most of this file just by typing F8 in the right places. Remember that when we type F8 on a line that starts with 2 red stars, EEV treats that line as a comment. So I'm going to start here. Note that it says in the bottom of the screen that this is a comment. We are going to run this to download some files. Now the files are there. This find QA here shows a certain file at the window at the right, but we don't need to pay attention to that. And this thing loads that file. So when we load that file, it defines some functions here that are going to be used by the rest of the example. Now we can run this thing here. Note that we just defined some functions, and then we run these functions here. Find a output QA, and they show some things in the window at the right. These things are boring. When we run ADT insert with argument 42, it just shows a 42 in this way. The other ones show other numbers and so on. And what happens when we modify this function here, ADT2, by adding and removing advices to it. The idea is that people can run this thing here several times, watching the window at the right, because the results are going to be shown there. So, in the first moment when we run, sorry, let me run it again. In the first moment when we run ADT2, it just shows a 2, and then we modify it in a certain way and we run it again, and now before showing the 2 it shows a 1, mysteriously, and then we add something to be run after the 2, and we run it again, and now ADT2 shows these 3 things. And then we remove the advices, we remove these other things, and when we run ADT2 again, it shows only 2. It's impossible to understand that in the first time, so we can run that several times to see how things work. And now we want to understand what changes in the function ADT2, how it is modified internally. I'm calling that the internal view of the function, and we are going to compare several internal views of the function ADT2. I'm going to reset the function ADT2 by removing the advices and placing the advices on it again. And if we just print this function here, the symbol, the value of the function as a value of this symbol here as a function, it is something very ugly. But if we print it in another way with clprint1, then we get something that is much nicer, but it's not indented. And if we use this thing here, clprint2 instead of clprint1, it becomes indented. So let's try it again. Here is the current view of what is ADT2. So the original ADT insert is here, and here are some modifications that were added by the advices. And we can run these things many times to understand what each step does. But my suggestion is, in the first time, you just run everything very quickly, and then you run it again, paying attention to the parts that look more interesting. Now, I'm going to remember that here I printed the contents of ADT2 in several different ways, and now I'm going to show how we can do the same idea of printing something in different ways for Lambdas. That is something that I explained in the first part of the video. In this part of the demo, I define a function foo. This setq here defines O as the contents of the function cell of foo, and now we are going to print that O in several different ways. The default way is this one, is very ugly, but we can redefine how these things are printed by just running these lines. And if we pay attention at what's happening at the window at the right, we can see that we have several different printed representations for the same thing, and then at the last step we reset the printer to the default representation. And the details are here. If we run these lines here, they show the definitions at the window at the right. And this now comes the difficult part, in which we have to do something besides just running things with F8. We need a help buffer with buttons in the traditional sense, and we need to choose a certain button there, or any button there, and run metax ee set button on that button. So let me define a struct here, and this is the some help on what is that structure. I'm going to choose this button here, and I'm going to type metax ee set button. The message is a bit obscure, and now we have something that displays a lot of information about that button, and we can also run that with just F8. By the way, if we want to understand the code that's behind these things, we can run this sexp here. It is going to show the code here at the right. But anyway, this first line here, they display the output in the echo area. Let's try. And each one of them extracts a different part of the information on that button. And these other lines here create a 3-window setting in which the help buffer is shown here, and the result of some other thing is shown in the third window. Let's try. So now that we have well, I said that we needed to choose a certain button and run metax EE set button there. We have done that, so now this variable EE button contains information about the button, and now we can run this part here as many times as we want to try to understand what are the values of these things here, and how some things start with a value that is very complex and very difficult to understand, and then we extract the more interesting parts. And the details, as I said, are here. That was the end of the demo, and my question is, what was your reaction to that? If your reaction was more like wow than like Berg, then you might like the last part of the video that I recorded in March. That was very technical. When I recorded it, I thought, oh my god, this video is very bad. Only the hardcore EEV users are going to like that, and there are less than 5 hardcore EEV users in the world. But anyway, if you saw that introduction and you think that these things are interesting, you can execute any one of these expressions here and take a look at the final part of that video that describes how I wrote some functions for exploring buttons. If you execute this sexp here, it plays a part of the video starting from the position.
Awesome.
If you execute this one, you go to the subtitles in HTML, and if you run this one, you go to subtitles in another format. And that's it. No, sorry, I said that's it, but I forgot a very important part. I had prepared this slide here to explain some design decisions behind EV and why there are so few users of EV, and let me do that. The thing is that my working memory is very small, and I need examples that are easy to visualize. Ideally, examples that are easy to run and that I can compare the outputs of different ways of running them. And for me, understanding specifications and API is not enough. Examples work much better for me. Also, I make lots of mistakes when I type, so I need ways to run my executable nodes by just typing F8 and meta-E. And most people in the Emacs channel and in other places recommend executing sexp by typing meta colon like this, but I hate that. I think that meta colon and ILM are for people who type well, so not me. And also 99% of what I do is scratch code. Very few things that I do go into production, between quotes. So most of my tests are not automated tests. They're just things that I run with F8, and they don't include the expected result. And many people feel that this is very, very, very wrong. Tests must mean automated test. Also, and this is very frustrating, EEV has lots of non-users people who have tried to use it, but they said that they couldn't figure out how to use it. They couldn't understand what would be the workflows for EV. And there's the same that happens with me with code blocks in org. I'm still at the point in which code blocks in org just feel wrong. I still don't understand how to organize my workflows around code blocks. I said that AEV has very few users, and they are all very weird and very busy. And I decided that all my bloggish posts about AV would be things that they can run in a few minutes, just like the demo that I showed a few minutes ago. I said like the examples in the rest of the video, but I forgot this slide and I'm recording this after the demo. So that's it. Thanks.